That's confusing.
Good.
All good.
Okay, so
And
I
then,
still have to call back. But just that this is in blank space.
yeah, okay, yeah, that works.
All right, we're gonna go through this in just 1 second. All right, so for this first one, you should have. So we have a horizontal shift left 4 and a vertical shift down 5. So you have the vertex form, which is this is you have A, H, and K. Like so. A tells us, I'm going to break this down in a second, so you don't have to copy that part down. But we don't have an A value. This +4 tells us that we're going to shift left 4. If you write the whole thing horizontal, that is better, but knowing that you're moving left and right. But really what's underlined you need to have is the shift left 4. And then vertical shift down 5 is based off of this K value. We always do opposite with X. And then we do exactly what it says with K. So it'd be just a vertical shift left 4 and a vertical shift down. Sorry, horizontal shift left 4 and a vertical shift down 5. The next one, we have the X +3. That tells us that we're going to shift to the right. So it's everything that's in red. Let me get rid of this box. So everything in red. So we have a shift left 3. And I guess if you erase it, I was going. And we have a reflection over trying to save time, I have to write this again. But a reflection over the x-axis because of the negative being out front. And then you have a vertical stretch by a factor of 2. Notice that it is +2. The negative part talks about the reflection, and the stretch factor is the absolute value of A. So if A is negative, that means that it's a reflection. But if A is greater, if the absolute value of A is greater than 1, it's going to be a stretch. If it's between 0 and 1, we're going to be a shrink. And I have a slide in a second that will show everything for this. And the last one kind of includes everything. We have a shift right 1 and up 3. And then we have a vertical shrink by a factor of 1/2. And that's based off of where A value being between 0 and 1, the absolute value. Okay. For our interval notation, some of you, this may be your first time seeing it. Again, I have a slide for you in a second that will help you out with that. But 3 is less than X, which is less than 5. That's our compound inequality, compound and I should say. So you have a lower bound and an upper bound. And then since it is just less than, we have parentheses. So I call these open and closed. So these are open endpoints or open boundaries, whatever you want to call them, where they're not included. Some people call them inclusive and exclusive. I call them open and closed. So these are open. This 4 is closed. So we have a bracket that means that it includes it, where it's greater than or equal to. And then number 6, we have 2 because it's X is less than something, or, so it's a compound or. And so we have this, and then in the middle, we have a union. It does not have any operation or any value to it. It just says that both of these are the part of the answer, if that makes sense. So just be aware though, you should have seen this in Algebra 1. But if not, I'm going to give you 2 quick slides to kind of help you out with this so that you can use it. And it will help to graph and answer any characteristics that we have today and tomorrow. All right, so if you struggle with this, here is basic transformation. So all this is in vertex form. Today we are talking about all three forms of graphing. We have vertex form, we have standard form, and factory form. If you want, I'm not going to spend a whole lot of time on this. If you want to take a quick picture of it, you can, and then copy it down into your notes later on. But you do need to know this. You need to know that if you have a negative value out in the front for your A, that is going to make it, instead of a U-shaped parabola, it's going to flip down to be an N, or it's reflected over the x-axis. Then we talked about kind of the absolute value of A. If it's greater than 1, it's a stretch. If it's less than 1, or sorry, between 0 and 1, it is a shrink. And then you're going to have a horizontal shift left to right. We always go the opposites. So so a positive H, we're going to go to the left. A negative H, we're going to go to the right. And then K tells us about up and down. So if you want to take a quick picture of it, I'm not going to keep it up for very much longer, but we will talk about that. We'll talk about graphing, but not necessarily all of the transformations as we go, but it will help out. And it will be on your quiz as well. All right. So if you, like I said, I can come back to this at the end today as well if you need. Interval notation, if this is the first time you're seeing it, I would highly encourage you writing this down. Again, you can take a quick picture. I'm not going to spend a whole lot of time on it, but it's a good frame of reference. Just because I want to get into, we're going to check the homework, and then we're going to talk about graphing today. So if we talk about inequality notation, it is a little bit inferior in some ways to interval notation. So you can have your minimum and maximum of your set. I like to call it lower bound and upper bound just because it makes more sense in my brain, but both will work out. Parentheses are open, is kind of like what I say, in that they are not included or not equal to, meaning that if we're at that first value of 5 right here, this 5 is not included in the interval, but 5.000001 is included. So any number after 5 would not include 5. Whereas the second one, x is greater than or equal to 4, that means we start at 4 and 4 is included, and then we go anything above that. And again, we can add in, we can have 2 intervals, 3 intervals, 4 intervals, where we just put a union in the middle. Any questions on that? Again, if you have not seen this before, then take a picture of it. You can come in for help tomorrow. I'm available tomorrow, 7:45 to 8:15. Be able to help you out. You do have a quiz on Monday. So in fact, just all you'll have is a pencil.
Right on.
And we'll take it in there. Computer or anything like that. All right, so we're gonna go through the last homework. I know we haven't seen worksheet number 1. Did we go over worksheet 1 yesterday? Okay, I'll go over that at the end of class today. But just for purposes of this, we're gonna go over this, and it does tie into what we talked about later today a little bit. So this shows you all the work, not all of it, but the vast majority of it. So factoring, we need to make sure that we are able to factor that. Kind of talked about factoring yesterday and how to factor when A is greater than 1. There are more than one method, but like I said, I think guess and check is the most efficient. 2, factoring different the squares. 3, we just need to get equal to 0 first and then factor out the GCF. And 4, you should GCF as well. The main thing when checking through these is do not erase the stuff that you have. That will kind of defeat the purpose. What you should do is find out where you went wrong, write the correct answer out to the side, and then try to find out what mistake you made. If you made the same mistake all 4 times completing the square, we really need to try to make sure that we understand what we're doing and how to fix it to do it properly. Now, number 6 and number 10. There are some ways that split that up when you do the quadratic formula or complete the square. I am not opposed to keeping it as one fraction for right now. Just know that in the near future, you will be required to split that up. Those purposes, the reasons why when we get the complex numbers next week. But for this week's purposes, if you gave me what's boxed, or if you gave me 2 plus or minus root 19 over 3, those would be accepted. But after the quiz, you'll find out why we split that up. Same with number 9. I didn't write it, but you could have 1 plus or minus root 5 over 2. But make sure for number 8 that you do not write 1/2 plus or minus 5. If you have actual numbers, not radicals, you must simplify to whatever that number is. So we simplified to negative 11 over 2 and negative 9 over 2. You must have those two. Any questions on this page or anything you want to see worked out? I know there's another page going to work, but anything on here first? 8, yeah. Factoring or put the square, right? Or the square. So what you want to do is you want to isolate and get the constant on the other side. We have something like that. We need to get A by A. We need to kind of trick A to be 1. There's 2 different approaches to that. I talked about factoring out your 4 and leaving it there. And so from here, what we would do is we would say, let's take half. So we can, there's 2 ways to kind of go from here. I'm going to show you my way and then show you another way that might be beneficial to you. But we're going to take half of negative 1 and square it. So we're going to get 1/4. We're going to add 1/4 right here. However, we are really adding 4 times 1/4 because we factored that 4 out and left it there. So we're really adding 1 to both sides. This is just manipulated because of that. And so then this side we can write as 4 parentheses x minus 1/2 squared is equal to 100. We can divide both sides by 4. Get x minus 1/2 is equal to plus or minus 5. And then we would get 1/2 plus or minus 5. You cannot leave a number like that because those 2 numbers can't combine. It's when you have a square root that you don't need to. So we would need to say x equals 1/2 plus 5 or x equals 1/2 minus 5. And so that's going to be 10 over 2. So that's 11 over 2. And that's going to be negative 10 over 2, which is negative 9 over 2. So that's how I would go about it at this step right here. What some people will do before they do the 1/4 and everything like that. So imagine that this was still blank. Is you could divide both sides by 4 right here. And you would end up with x squared minus x plus blank is equal to 99 over 4 plus blank. And then you can complete the square normally. Half of this is still 1/2. 1/2 squared is 1/4. So we would add 1/4 here. And we would add 1/4 right there. And then that just becomes 100 over 4. Doing the same math, just in a slightly different manner. So whichever way works best for you. Like I said, there's no one way to do some of these things. Yeah.
2 with the mixed fraction.
No, so you want to leave everything as an improper fraction. Reduced improper fraction is what we're looking for. No decimals, no mixed numbers. Good question. Other questions on that page?
Over 6.
6.
Yes.
So I'll do this the other way, just so that you can kind of see what both work the same way. So we need our constant on the right side, everything else on the other side. So we're gonna say 3x squared minus 4x. Like so. I'm gonna factor a 3 out. And then from there, you could leave the 3 there, take half and 4/3 and work from there. There's nothing wrong with that way that I just showed. But what we could also do, if that is a problem for you, because you forget to multiply the 3 out, what you can do is you can divide both sides by 3, but you need to remember to divide the right side by 3. If we do that, we end up with x squared minus 4/3 x. We just cancel these out. Plus blank is equal to 5/3 plus blank. And then we would take half of negative 4/3, which is negative 4/6, and square it. It's really negative 2/3. And that's going to be 4/9. So in this case, when we do that, we are able to just add, we are adding 4/9 to both sides. We don't have to tie in the first number 3 right here. So that's another, you would end up doing it, but it's just a different way of kind of computing it. So here we have x minus 2/3, because what we talked about yesterday is it's always going to be this number right here, the half of the b term. Unless you really want to factor that, you can. You can also do some multiplying and whatnot, but the easiest way is just to recognize that it's the half of b. We have squared, and then we would need to combine these. So 5/3 is really like 10/9, so we're going to end up with 14/9. We square root both sides. We get x minus 2/3 is equal to plus or minus. We would need to simplify this. We can split this up to say root 14 over 9 by root 14 over root 9. That's going to be plus or minus root 14 over 3. And then we move our 2/3 over. You can write it like that, or you can combine it in one fraction, like 2 plus or minus root 14. My fault. It should have been at this point not 14. This is 15 over 3. So that should be 19 over 3. My fault. Okay. Sorry about that.
That problem, when we were doing it, does the sign like for 2/3 just depend on what the middle two sign is?
Yes. So when we factor that, it's always just going to be including that sign of b. So if b was positive, it's half of b that's positive. If it's negative, it's going to be that negative. Good question. All right, looking at the next page, back page. So you're still solving by square roots. If you have a quantity squared, like 99 out of 100 times, you want to square root that. Okay. If not, you need to do some foiling, all that. We don't want to go down that route. We talked about yesterday for something like 15, where you take the square root, you want to use plus or minus on one side. You're more than likely going to get 1 where the x's cancel out. That does not mean automatically no solution. You need to solve the other equation. $17, you could have solved any of the, you could have solved by factoring, could have solved by quadratic formula, or complete the square. I would really not advise complete the square just because A is not 1 and B is odd. 18, I would highly advise you to solve by square root. If you are not solving by the square root, you would need to FOIL that and use quadratic formula. But it's going to take forever. I would, like I said, highly advise not doing that. 19 obviously factors because it shows that factors, but you could have used quadratic formula. You could have used completing the square, but that's going to get kind of messy really quick. 20, since B is, it does not factor, so we can't factor, we can't square root. So you can quadratic formula or complete the square. If you want to avoid fractions, I would quadratic formula. You can complete the square on it. 21 factors, but you could quadratic formula or complete the square. But factoring is the most efficient. And then 22, you can either factor or factor quadratic formula. You could complete the square, but know that b value is 0, or you can square root. Do all four. Square root or factor is the easiest problem for that. If you can square root or factor, you should do that. If not, then go to linear square for quadratic formula. Yes.
Did you do number 16?
Number 16. So 16, we got 2/3. X minus 7 squared. So we want to isolate the square term. We're going to move our 4 over. Get 24. And then we're going to multiply by 3 over 2. So these are going to reduce to 1. We're going to get x minus 7, I'm sorry, squared. 24 divided by 2 is 12, times 3 is 36. And then we would square root both sides. We get x minus 7 is equal to plus or minus 6. And then you would, at this point, once I get plus or minus, I would just break it up to say x minus 7 equals 6, or x minus 7 equals negative 6. And then you would get that. Do not move the 7 over and then say plus or minus 13. Common mistake, kind of. Other question? All right, solving is key. We will use it today, but you need to make sure that you are understanding that once we get past this and we're not saying solve by the quadratic formula, solve by this, it is your decision as to what works best. Like I said yesterday, quadratic formula, complete the square works 100% of the time. Square roots and factoring is going to be a lot more efficient if you can do it on those types of problems. All right, so we're going to jump into some graphing. So you need to know the 3 forms of quadratics. I'm going to hand out little strips of graph paper to follow along today, but you need to see the paper and or whatever you take notes on. Understand these 3 forms. Specifically, if you're like, you need to write this equation in this format, you need to know what format that is. We have talked about standard form quite a bit when you talk about solving. That's the most common representation of quadratics. Vertex form we talked about with transformations. That is the easiest form to graph in because they give you the vertex. Kind of nice. Intercept form, they give you the intercepts. This is also called factor form. And they give you your A value. The one thing that remains constant in all of these is your A value. So if you are graphing, once you find your key information and what they give you, you need to utilize A, and we'll talk about how A impacts graphing based on the parent graph. Okay, but you need to know all 3 forms. You need to know what they represent as well. We talked about vertex form pretty heavily in the transformation sense, but you also need to know that it gives you your vertex in H and K. On intercept form, P's and Q's mean that they are giving you the x-intercepts where you cross the x-axis. Standard form only gives you your y-intercept, but it's kind of just a byproduct of the way it's set up. Your y-intercept is 0, C, and that will be the only information you can really extract. You have to do a lot of other math to find the key stuff. Yeah,
Are there two X intercept?
there could be two, could be one, it could be zero.
So if there are they function for the X intercept?
Right.
So
So you would have an x-intercept at P0 and Q0.
What is the vertex one?
Your vertex, which is at HK. And this will give you your y-intercept, although it's not super pertinent, but it is a piece of information. Okay. So the best one to graph is vertex form. However, we see everything in standard form for the vast majority, and intercept form is not as common, but it will be a possibility. So we're going to look at f of x equals x squared and talk about the parent graph and how we can build every other graph based off of this. We really need to know some characteristics. We need to be able to apply some of these things and know kind of how to work from just finding the vertex. So technically, f of x equals x squared is in all three forms. Right? It's in standard form, it's in vertex form, it's in intercept form. Doesn't look like it, but it is kind of in those. So you can graph this and then translate your characteristics based off of what we are dealing with. Now, for the parent graph, we're going to graph this using a T-chart. We're not going to do this every time, but this is just to refresh you on what the parent graph will look like. So typically, we plug in -2, -1, 0, 1, and 2. That's for almost all parent graphs. That will expand some once we get into other types of functions, but for the most part, that's what we typically plug in. If we plug in -2, f of -2 is -2 squared is +4. If we plug in -1, so we get -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So from there, we can plot those on our graph. And we can see our basic kind of parabola there. Now, something that we don't graph because we really only look for 5 points is you could add in 3. If you know what 3 squared is, hopefully we know it's 9, or we can add in -3, +9. That is another option of points if you need them, but that's not included in the whole. We don't typically graph those unless for some reason we need to. So, like I said, we only graph those 5. We have something called an axis of symmetry as well that runs a vertical line through your vertex. So vertical lines are represented as what type of equation? X equals y equals. X equals. So our axis of symmetry is going to be x equals the x value of our vertex, which we found was 0, 0. I didn't write that down yet. So once we have 0, 0, we can find that. And then what I want to talk about before we do all the other characteristics is how we can redo the parent graph over and over again, because every quadratic is somehow related back to this parent graph of these x squareds. So if you were imagining that this is like a city map, the x and y axis is a city map. Think about like New York or other cities that are on the grid. Atlanta is not like that for some reason. Grids make a whole lot more sense. But let's imagine that we were in a city where everything was a perfect grid. And if I were to say, let me zoom in here just so that you can see. Okay, if I were to say we are starting out at the vertex. And I want to get to this point, and you were giving me directions, what would you say? Right one up one. So we want to think about that when we are graphing this. If we are going from the vertex to our first point, it's not going to fit, but from here to here. It's Sorry, I thought I would zoom in, but it's gonna be more pain. So from here to here, we would say, this is our vertex. And this is right one, up one. Okay, then there's a few different ways to go about it, but I go back to the vertex. And if I were to go from the vertex to this point and you give me directions, we would do what? You would say what?
Up 4, right 2.
So I would say right 2 first, but up 4 is okay too, but I would say right 2, up 4. Every quadratic is going to be related to that in some way. And then I use the axis of symmetry. You could say same things here to the left, but I just say that the axis of symmetry just flips these over. So we are, this point 1, 1 is 1 length away from the axis of symmetry to the right. So we're going to go 1 over there. This is 2 points, 2 lengths away. So we're going to be 2 lengths there. So I really only end up graphing 3 points and then reflect over the axis of symmetry. Right? Everything is related to this. You can build every quadratic based off of this. Hence the parent graph, everything else is a version of that. Okay, we need to also, any questions on that? If you want to do left and left 1 up 1, left 2 up 4, I'm perfectly fine with that as well. If you want to plug in points, I'm fine with that. I'll kind of explain that as well. But domain, we need to know for all of our quadratics are going to be all real numbers because we can plug in any number into our x. And we're going to get a number back. And we also cover the entire x, y, or sorry, the entire x-axis because our arrows go in opposite directions. Our range, we start, there's nowhere in our range is going to reach here. We're going to start here at 0 and start working our way up. So our range is going to be 0, including 0 to positive infinity. And then our zeros are just the x value of our x-intercept or where we cross the x-axis. So we have a 0 of 0. Now that if we ask for x-intercepts, we want those written as ordered pairs. And then our y-intercept in this case happens to be 0, 0. Which is also our 0. That's not always the case. Okay. So hopefully we've been reminded of that from previous knowledge. So any questions on that? Yep.
The zeros, where does that come from here?
It's just the x value of the x-intercept. So since we have our x-intercept of 0, 0, it is the x coordinate of that. We can also find zeros. We did this yesterday. If we find zeros, then all we do is just set y equal to 0. So we'd say 0 equals x squared, and then we would square root both sides. We get x, that'll come into play. All right, we're going to graph one of each just because we don't have as much time to go through in much detail. And we'll talk about some characteristics along the way. Okay, what we want to think about here is we have f of x. So you're going to have to kind of flip back and forth between your graph paper and your notebook paper. And we have f of x equals x plus 3 squared minus 1. What form is that in vertex? So if we're in our vertex form, we should be able to easily get our vertex. So what is our vertex going to be in this? -3, -1. So we're going to go ahead and put that on the graph. I'm going to plot that point. Next thing we need to be able to take away is our a value. What is our a value in this case? 1. So if there's nothing there, it's understood 1. So that means it's going to open up. We can also get our axis of symmetry to be x equals -3. When a is 1, all that means is we are just moving our parent graph. Talking about transformations, we are shifting it to the left 3 and down 1. So that means that we can still use our directions exactly as we wrote on the last page. So from our vertex, right here, we can say right 1, up 1. And that gives us a point. If we go back to our vertex, we go right 2, up 1, 2, 3, 4. And the reason why I always go left and right first is because if you don't remember that, you're just going right 1 and you're squaring 1. That's 1. Then you're going right 2, you're squaring 2, that's 4. If we want to go to the next one, we would just say right 3, 3 squared is 9. That's kind of what we're talking about when there's no a value, when the a value is just 1. And then from there, if you want to go left and everything like that, that's fine. I really just say that this point is 1 away from the axis of symmetry, so we're going to go 1 to the left. This is 2 away, so we're going to go 2 this way. We look something like this. That's the graphing aspect of what we're doing. Vertex form is the easiest to graph. Okay, any questions on the graphing part before we do characteristics? All right, our domain should be consistent in all quadratics. We should be going from to all real numbers. Remember that we're using interval notation, so negative infinity to infinity. Our range, what is our smallest y value? -1. And then what's our largest y value? Infinity, because we're going to keep going up. We do not include infinity, but we do include -1. Just make sure that you have that bracket on -1. And then our zeros we can represent pretty easily from our graph. So what are we can get them from our graph, I should say. What are our zeros of this? -4 and -2. Remember that we're just using the x values. You can write x equals -4 and x equals -2 if you want. Now, can we find our y-intercept pretty easily? How so? I didn't really pay attention to it when I was graphing it. So you could, by using what we just talked about in a second ago, there's 2 ways to do it. If it's not on the points, so I have these 5 points graphed. None of those happen to my y-intercept. I could do 1 of 2 things. I could say, right, 1, 2, 3, we happen to fall on the y-axis, so that would go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could find it that way. Okay, but if it's far away, we know that all y-intercepts have what in common? X is 0. Okay, let me just question in a second. So we could say that our y-intercept, we can plug in 0 for x. And solve this out to be 9 minus 1, which is 8. And then we need to write it as an ordered pair of 0, 8. Let's go.
Only at 1, 3, or -1, 3, why don't we plot it?
It's -3, 1, because our x's go first, but we go -3, 1, because we pulled out our vertex. This is our x minus h plus k. So we have a 3, so we're going to go left 3, and then we're going to go -1. That's the opposite of x. And then whatever our k value is, our up and down. So you're just taking that away from the vertex. Okay. All right. I do want to get through these, so we're going to go into this format. We're going to go f of x equals 3x squared minus 12x plus 8. So, all right, what format is this in? Standard form. Standard form is not very helpful in graphing. It does give us our y-intercepts. Okay, what we want to do for standard form is you're going to use part of the quadratic formula to say negative b over 2a is your vertex, is the x value of your vertex or the axis of symmetry. You're not going to be provided that. I'm providing it to you now so that you have it. So we need to find that. First off, it needs to be in order. Standard form is always in order of highest degree to least degree. And so we would plug in. So we would say negative 12 over 2 times 3. And that's going to become 12 over 6. 12 over 6, which is 2. So the x value of our vertex is 2. And our axis of symmetry is also x equals 2. Based off of quadratic formula, I'm not going to go into great detail about that, but it does come from that. Now, to find the y value of our vertex, we just plug in 2 back into the equation. So we're going to say f of 2. We don't have a calculator, so this is something that you need to just watch for minor arithmetic mistakes. Watch for signs. So 2 squared is 4 times 3 is 12. 12 times negative 12 times 2 is negative 24 plus 8. These two make negative 12 plus 8 is negative 4. So we have the point 2, negative 4. So to find your vertex, and that's really all you need from this, is to find your vertex is negative b over 2a. Once you do that, it is the exact same graphing as what we did before. However, you need to make sure that you watch out for a values. So we have an a value of 3. So that's going to stretch our function by 3. If you remember back from the very beginning. All right, how we go about graphing that? We go to 2, negative 4. We plot our vertex there. We have a axis of symmetry, so I only have to plot 2 more points. From there, our parent graph would be right 1, up 1. We have been stretched vertically by a factor of 3. So we're going to go change the up values because the left and right is horizontal. We're going vertical. So we would say right 1, up 1 times 3. So we're going to go up 1, 2, 3. We have a point there at 3, negative 1. We are stretching the vertical aspect of it, which is the up value. Okay. If we go back to our vertex, parent graph, we go right 2, up 4. But we're going to go up 4 times 3, which is 12. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Have a point right there. We come back and reflect over the axis of symmetry. We look something like that. Okay, any questions on that? If you're like, I don't like that. The other option that you could do, I don't advise this because you don't have a calculator, it's going to take a while. Once you learn parent graphs, there's a reason why I'm teaching that way because it is kind of efficient, is that once you get to negative 4, you could just plug in the next 2 x values. And that will give you those points. You'll do the same math, everything, you'll get the same points. That's another option that you could use. Okay. I do want to get into graphing a factored form, so I'm going to go through this kind of quick. Domain and range. Domain is all real numbers. Range, we're starting out from our y value of our vertex. We include it. Note that if we have a reflection, that changes the range around a little bit, so just pay attention to that. Our zeros, we don't have good whole number zeros. So how can we find zeros? So we can plug in 0 for x. Oh, sorry, that's for a y-intercept. We can factor it. Probably not going to factor if we don't have whole numbers. So what we're trying to do is say we're going to plug in 0 for y, which I think is what you were trying to say. And we have something that looks like this. We can try to factor that. I'm not 100% sure if that factors off the top of my head. So we can use quadratic formula. That's 144 minus 24, 48, 96. 144 minus 96 is 48. So we're going to get 12 plus or minus 48. We take a 16 out. We can say our zeros are that. Not the nicest of numbers, but that's where solving comes into play. We do really need to make sure that we understand that.
Didn't you just do 2 plus or minus 2?
You could do that. So you could do 2 plus or minus 2 root 3 over 3. That's fine. 2 by itself plus or minus 2 root 3 over 3. Okay. And then our y-intercept, the good thing about standard form y-intercept is just your c value. We have 0.8. We also graphed it. So you could have completed the square on that as well. I would advise against it, but you could. All right, real quick. We don't have a whole lot of time. This is in factored form. or intercept form because it gives us our intercepts. Okay, 2 routes to go here to find your vertex. I'm going to show you kind of a quick way that if you know what you're talking about with this, it's going to help you out. But we have f of x equals negative parentheses x plus 1, x minus 1. What we're going to be able to tell from this is our zeros are this, x plus 1 is equal to 0. We get negative 1 and 1. Okay, we do need to bring back into the fact that we have an a value of 1. But we could graph these, negative 1 and 1. Okay, one thing that you should recognize from this is that all parabolas are symmetric about the axis of symmetry. Therefore, if we split that down the middle, our axis of symmetry is x equals 0. Okay, because that's directly in the middle of those 2 points. Therefore, our vertex must be at 0, something. If we know that, we can find f of 0 now. So this is for our vertex work. And I'm kind of going all over the place. But f of 0 is negative 0 plus 1 times 0 minus 1. That's going to be negative 1 times negative 1, which is going to become positive 1. So we have the vertex at 0, 1, which is right there. We need to carry over the fact that a is negative 1. Now that we have our vertex, we can go right 1, down 1. We've already graphed that point right there. We can go right 2. Instead of going up 4, we're going to go 4 times negative 1, which is negative 4. So we go down 1, 2, 3, 4, and then reflect that over. Intercept form is a little bit tricky. If at all it fails and you're not 100% sure, you can FOIL it out. This FOIL out will be x squared minus 1. And then you can distribute that. That would be y equals negative x squared plus 1. You can graph from there, whether it's standard form or vertex form. Okay. So that is all we have for today. I'm available tomorrow from 7:45 to 8:15 if you need help on this. This will be on your quiz on Monday. Hope you have a great rest of your day. Please be working on practice problems number 3. And be on the lookout for your prereq assessment being released later today.